So let's look at the difference between multiplying and factoring. So if I gave you the numbers 2 times 3 times 5, you would multiply these together and get an answer of 30. But if I went to the other side of that and said, what are the factors of 30, you'd probably go through and say, well, that's 6 and 5. 6 is 2 and 3, so it's 2 times 3 times 5. So whereas multiplying puts it together, factoring takes it apart, and they're related to each other in that way. So what we're going to start looking at with polynomials is either multiplying them together or factoring them apart, and that's where the rest of this chapter goes. So we really have two methods as we start looking at multiplying things together. We have the box method and we have distributive property. Both will do the same thing. This one, the box method, is going to keep us a little more organized. Now, even though today we're just looking at basic distributive property or single terms being multiplied in, this will probably work a little more convenient. This is a good thing to have to keep us organized as they get more advanced. So I'll show you both. You can use whichever one as you go through. Let's start with the box method. The box method means I'm going to make a box where each of my terms, so 3x plus 1, gets their own little part on the top row, and 2x is on the column. So then I go through and I multiply whatever in a box, it's valued next to it and above it. So it's going to be 2x times 3x is 6x squared, and then 2x times 1 is 2x. So this together gives me 6x squared plus 2x. What distributive property, as you should have learned it, is you're going to multiply this term to each term inside the parentheses. So that 2x is being multiplied to each term. 2x times 3x is 6x squared, and 2x times 1 is 2x. Now, it gives me the same answer, and it should. This should give us the same result. This one's relying on us drawing kind of arrows. This one's in a box, but it's still going to get us there. As things get more complex, I would recommend using box method to be organized, but let's start working through and looking at them. First one we have is a negative x cubed on the outside. Anytime negatives come up, you have to be careful. A lot of the mistakes that occur with the negatives. So this is going to be multiplied to each term. We'll think distributive property here. Negative x cubed times 9x to the fourth is negative 9x, and then we have 7 of them, so negative 9x to the seventh. Negative 2 times negative 2x to the third is going to be a positive 2x to the sixth, and then negative x to the third times 7 is negative 7x to the third. Now maybe this one was probably not the best one to start off with just distributive, so let's think, what if we did box method? We could have done 9x to the fourth minus 2x to the third and 7 with a negative x to the third there. So here it's going to be a negative 9 x to the seventh. Then we have negative 2 and negative 1 is positive 2, and that's going to be x to the sixth because we have 6 x's. And then negative 7x to the third, which gives us 9x to the seventh plus 2x to the sixth minus 7x to the third. Same answer, and that's good. Let's go to number 2. We'll draw the box. I have 5n times 3n minus 3 is 15n to the fourth. 5n times negative n squared is negative 5. Pay attention to the number first. Negative 5, and then n to the third. And the last one is 40n. That's 5 times 8. So our answer is 15n to the fourth minus 5n to the third plus 40n. And you should not have like terms here, assuming you didn't have like terms to start with. Number 3, well, suddenly this term is on the other side, and that's fine. Multiplication, it can go around this way. I go 2b times b is 2b squared, and 2b times 11 is 22b. Now number 4, we have a negative 8y to the third out front. Let's just try distributive property. If you have to use box method, that's fine. You always can go back to that. The key thing is you're being organized and getting the correct answer. So negative 8 and negative 7 gives me a negative 56. Y to the third and y squared gives me 5 y's, because I have 3 and 2, 5 together. Here I get a positive 32, negative times a negative, and this is going to be y to the fourth. And the last one, it's a negative 1 times that term is going to be plus 8y to the third. So now we've done the multiplying, we're going to start going backwards, and what we look for here is the greatest common factor. The greatest common factor is what every term is going to have in common. We can take that out and reverse the process we just did with multiplication to find our kind of initial start. We look in the factoring. So I look initially, and I see all of these have a 5 in common. 5, 25, and 45. That's a good start. Always look at those coefficients first. Then look at the x's to see what the minimum has is. And what I mean by that is I have x to the third, x squared, and an x. So all of them have at least 1. This one has 2, this one has 3, but the minimum they all have is at least 1. So I can at least take 1x out of all of those. So now we go through each term. If I took a 5x out of here, the 5 is gone, leaves me with a 1. One of the x's is gone, so that's x squared. 25x squared, if I divide out a 5, I have a 5 left, and I have 1x left. 45x, I divide out a 9, I'm left here. You don't have to write the 1 here, but this would be 5x times x squared plus 5x plus 9. You would say that your greatest common factor is 5x. Now we have something like 45b plus 27. I look here, 45 and 27, let's try 3 first. Let's take a 3 out. If I did that, I'm left with 15b plus 9. Now, 15 and 9, though, still have a common factor between them. I could take another 3 out. So if I took another 3 out of it, now I'm left with 5b plus 3, and it's kind of reduced down enough. So what it should have done is gone 9, 5b plus 3, which tells us we could have taken the factor of 9 out from the beginning. But what that also shows us, if we don't see that factor to start with, as long as you pay attention to the answer you still had, you could look for more factors and keep factoring as you go. Let's do some more here. Number 7, we look for our common factors. 14, 42, and 21 all have a 7 in common. I have, let's make that actually a z, so these are all matching. So in your notes, make this 14z to the 4th. So I have z to the 4th, z cubed, and z squared. The minimum has is z squared. So now I'm going to take this out of each term. So 14 divided by 7 is 2. Take out 2 z's, I'm left with 2. Negative 42 divided by 7 is negative 6. I took out 2 z's of 3, I have 1 left. And then 21z squared, I have a 3 left. I had 2 z's, I took both out, so I'm just going to write the plus 3. So now it's 7z squared plus 2z squared minus 6z plus 3. Number 8, we're looking here, they all have a 4 in common. So I can take a 4 out, and I can take an x, because they all have at least one x. So in doing that, my first term is now x to the 4th. Then we go minus 6x squared. And then the last term, 8x, divide out of 4x, it's going to leave me with a 2. For number 9, we have g to the 4th, g to the 3rd, g squared, and g. So I know a g comes out. Now, just because there's no number here, there is a 1, but I have 1, 24, 12, and 4. If this had a different number, maybe I could factor a number out, but I don't have a common factor in all of them. Don't think just because these 3 have it, you could take out a 4. It's either all or none for right now. So actually, all I can take out of that is a g. So that leaves me with g to the 3rd plus 24g squared plus 12g plus 4. And if I look back at these, there's nothing each one has in common anymore. There's no common factors left. We'd like to do something with the 24, 12, and 4, but it has to be all of the terms in order to factor. Now for number 10, we look and we have a 6, 18, and 12, which means a 6 is in common. But notice how they're all negative. So let's take out a negative 6 from that. And x's, I have a 4th, 3rd, and squared. I'm going to take out 2. So by taking out a negative, I know it's going to change the sign on all of them. Divide negative 6 by 6, and I have 1. So that leaves me with an x squared. Negative 18 by negative 6 is 3, leaving me with 1x left over. Negative 12 divided by negative 6 is 2. X squared and x squared, that's gone, so I'm just going to be left with an x squared plus 3x plus 2. Now on number 11, we start to get some more stuff here to work with. 17 and 51 actually has 17 in common. Now we gotta look at x and y, we have a couple variables. So I have one x in both, and I have three y's in both. So 17xy to the third is the GCF. What's left after we do that though? So 17 divided by 17, so that's gonna be a 1. X divided by x, that's gonna be gone. Y fourth and y to the third, that leaves me with 1y. Now 51 divided by 17 is 3. X to the squared lost 1, so now it's x. Y to the third lost 3, so that's just a 1. There's no y there. So our answer comes out to be 17 xy to the third, y plus 3x. Same idea now for number 12. 9 and 27, I can take out a 9. M to the fourth and m squared, I can take out an m squared. N to the fifth and third, I can take out an n to the third. So what does that leave me? So here I'm left with a 1, 9 divided by 9. Had m to the fourth, took out 2, 2 left. Had n to the fifth, took out 3, have 2 left. Next term I have negative 3 left. M's are gone, n's are gone, so this is going to be 9m squared n to the third times m squared n squared minus 3. Now we get a couple of word problems that we have to work through and solve for us. So number 13 says a circular mirror, here's our mirror, is surrounded by a square metal frame. The radius of the mirror is 5x, and the side length of the frame is 15x. We need to figure out the area of the metal frame and write our answer in factored form. So this is something we've seen before. It's like the area of a square minus the circle, and we need to figure out that shaded region. So we're first going to do the square minus the circle. The square is 15x by 15x. So the area of that square is 15x squared. When I square that, like we learned last unit, we square both of them. So it's now 15 squared x squared, which is 225 x squared. For the circle, it's pi r squared. It's pi times 5x squared, which comes out to be 25x squared pi, but let's write that as 25 pi x squared. So we have the area of our square minus the area of our circle, and they want it in factored form, so we can look at common factors that they have. Well, they both have an x squared in them, so I'm certain that's coming out. 225 and 25 have a common factor of 25, so that can come out. Now what does that leave us with? 225 divided by 25 leaves you with 9 left over. X squared had both of them take out, so that's gone. Then 25 pi x squared lost its 25 and its x squared, so that's going to be left with minus pi. So our factored form of that is 25x squared times 9 minus pi. Now number 14 does the same idea, but it's kind of reversed now. It's going to be a circle minus the square. So the circle has a radius of 6x, the square has an area of 3x, or its side length of 3x. So for the circle, we're going to go pi times 6x squared, which gives us 36x squared pi. The square is going to be 3x squared, which is 9x squared. So we're looking for common factors. We can take out a 9 from both of them and an x squared. This leaves me with 4 pi out of this term. 36 divided by 9 is 4. X squared is gone. Pi is left. And then minus, I factored out all the terms there, so it's just going to be 1. So that's going to read as 9x squared times 4 pi minus 1.